Today we are going to start another session on the big data. And before going to start this session, I just want to introduce like Pankaj, and uh, we are taking session on the big data and Hadoop. So if I'm going to discuss about like last session, what we have covered in the last session. So in last session, if I'm talking about in last session, we discuss about like what is big data, and then we will talk about like sources of the big data from where we are getting that huge amount of data in our market, and then we also covered like history of a big data, how big data is originate, and then what we have covered next, we have covered like uh, how Hadoop came into the picture, and from where this Hadoop concept came, like and who is the founder of this Hadoop. So there is a guy Duck Cutting, who is a co-founder of the Hadoop, and how Hadoop. These are the story like we have covered. But today the important topic we are going to discuss, like Hadoop architecture, we are going to discuss like. Let's quickly revise like what we have covered yesterday. So this is a big data. So already I told you that big data is the term describe the large volume of data, and it also like carry all type of data, structured, semi-structured, unstructured, that cannot be stored and processed using a convention technology like databases. These are the some examples of the structured data and the unstructured data. So tabular kind of data, CSV, Excel file, these are some structured data. And nowadays 90% data in a market is completely generating unstructured data like PDF, audio, media file, and all the social media's activities. So completely unstructured data. And these are the definitions which we have covered yesterday. So I hope you can watch my previous video so you will get an idea about it. So I'll add the link in my below, in the description section. So here you can see that the 85%, 90% data nowadays is unstructured, and when we extract the useful information from these unstructured data, the structured data also become like huge. So already the existing technology like convention technologies like databases are not able to handle that huge amount of data. It will taking a lot of time processing everything, and these are the some sources from where we are getting the huge amount of data, like social media is the biggest responsible for generating these huge amount of data. These are the some other big data generated like sensors, smartwatches, social medias, now automatic car, Tesla is coming. So drones, through drones we are capturing images, everything we are monitoring nowadays. We are like we can say that data is a new oil nowadays. Okay. And these are the four characteristics of big data, like generally three, like volume, velocity, and variety. Variety referred like all kind of data we are getting, structured, unstructured, semi. Volume refer like nowadays we are getting a data in a bulk. In a 1 second activity we have, like 1 minute activity we have like discussed in our previous session, like how in a one minute we are getting huge amount of data. And velocity, like how fast we are generating data down. So YouTube is the best example, Instagram's reels, and you can see that we are uploading the videos, downloading the videos, so many activities going parallelly and all that. And there is another term, veracity, like uncertainty of the data, data, various type of data we are getting, various huge amount of data we are getting. So these are the some basics, like characteristics of the big data which we have covered. And definition is already we discuss in detail. And how big data is useful, all this is also covered, like you can do two market relevant product, new product development, cost reduction, time reduction, and decision making and scientific research. There are various, apart from these, there are various other field from where we are getting huge amount of data, like not a huge amount of data, we can, with the help of big data, we can expand our business and all that. Beautiful example yesterday we have discussed, like if you have a educational institute and you want to expand your institute, if you have a data about the students from various institutions, so you can directly call them and you can invite on your student and you can expand your business and all that. So this is a one example I have given, but you can apply big data on some different things in finance sector, banking sector. So everywhere nowadays people start working on the using this big data and expanding their business and all that. And who use big data? Every sector. I told you that: business, government, bank, healthcare, scientific research, educational institute, everyone nowadays using this big data. And contributor of the big data, already this picture we have yesterday discussed. I have a I know you guys are just yesterday we have a different ppts, but now today's are different for a Hadoop architecture. Especially I'm just open this ppt. And these are the Facebook IT giant companies like us. Facebook, like this is a talking about Google having a 12 data center all over the world, and 5 is under construction. And this is about a Facebook. In 2009 Facebook has was only 30,000 server, but in 2010, in a 1 year, he like Facebook just doubled their server capacity. Nowadays Facebook having a lot of data center all over the world. And what the big data challenges faces, so like storage, computation, data losses, cost, these are the biggest example of like big data challenges nowadays in market. So why not use RDMS? So as I told you that scalability is an issue, especially in RDMS when data is in terabyte. So as I told you that in RDMS we have a vertical scalability, but in Hadoop horizontal scalability. So what do you mean by vertical scalability and horizontal scalability? As I told you that in my previous video, I have asked you a question. So Anup, can you answer me like what is the difference between vertical scalability and horizontal scalability? Have you checked this thing? Are you there, Anup? Hello. Okay, no problem. So vertical scalability basically like when you want to increase the configuration of your machine. Okay, when you you have a system of 8 GB RAM and you want to increase like to up to 60 GB RAM. But in case of horizontal scalability, you can add more number of machine. So inside a Hadoop, like suppose you have designed the cluster in such a way, uh, your cluster will going to store like 1 TB of data, but unexpectedly data now coming like 2 TB of data. But inside a Hadoop, these are features you can add more number of machine, so you can easily like scale your cluster and all that. But in it is very difficult once you will do in RDBMS, so you need to down your server, then you can upgrade. But nowadays there are a lot of features coming in RDMS too, so they are just upgrading the clusters and all that. And database are designed for structured data only, whereas 85% of data is unstructured. Yes, in RDMS basically we deal with the structured data, not with unstructured data. Okay, so as data get bigger, indexes need to be a change, query need to be optimized. I told you that when in RDMS data get bigger, so you need to optimize your queries, and you need to optimize your queries, and then to achieve minor improvement. So it is very hectic to deal with the huge amount of data. uh, if you are, I'm sorry, if you are going to process on RDMS. We cannot add more computing power to increase performance. So I told you that horizontal scalability, is not possible. And hardware cost, because inside a RDMS, hardware cost is there, like database license and cost, everything is there. If you need to purchase any, we know that Hadoop is a open source technology. You can easily download the Hadoop package from the Apache website. Okay, and here we can see what our solution must have, like handle a high volume of data, data losses should be avoided, horizontal scalability, cost effective, easy to work on. So even for a non-programmer or a new programmer, you can use this this technology. So as I told you that these are also a property of Hadoop. So means you are looking, your cluster will handle a huge amount of data. So suppose you have designed your cluster for like 100 for a 1 TB of data. You are just assuming 1 TB of data you can get in a future. So but unexpectedly data is increased, so you can add number of machines, so you can easily handle that huge amount of data. The second activity, like data loss, should be avoided in RDMS cases, like in Oracle, in older technologies, there are very high chance of data losses and all that. But inside a Hadoop, there is a one benefit of replication. Like by default, there are three replication factor, and if you want to increase or decrease, it's up to you. You can increase your replication or decrease your replication. But inside a Hadoop, by default, there are three replication factor. It means that if you are going to load 1 GB of data, so it means that you are loading three times of it, like 3 GB data over the cluster. Mind it replicate your data on different nodes, and as well as different rack. It is loading your data. Okay. And other thing, if I'm talking about like horizontally scalable, you can add the number of cost effective. As I told you that Hadoop is like um, work on commodity hardware, like cheap hardware. You can easily work on the cheap hardware, and but where other hand, like RDMS need a very high configurations, RAMs, everything, and easy to work. Even if you don't know programming and all that, so still you can work on a Hadoop. So these are the some benefits of Hadoop. Here I just mentioned like what our solution must have. So these are also going to be Hadoop properties. So here you can see that Hadoop meet all the three all their requirements, not a three requirement. As data grow more, node can be added seamlessly. Work faster than RDMS. Data replication prevent data losses. Hadoop is cost effective because commodity hardware can be used. No specialized hardware is needed. Hadoop is an open source and freely available, so no license fees. So these are the some benefit of Hadoop through which you can get this. And RDMS versus Apache Hadoop, I don't want to waste my time on this. We already know the benefit of Apache Hadoop over the RDMS. Okay. And so here we can see that like Hadoop architecture. So inside a Hadoop, we have a three properties, like three core component, like HDFS, Hadoop Distributed File System, and then MapReduce, and then the third one is Hadoop Yarn. But as I told you that in Hadoop 1, something different. In Hadoop 1 versus Hadoop 2. So in Hadoop 1, there is no such concept of Yarn, but in Hadoop 2, there is a such concept of Yarn came into. Through Yarn, like Hadoop now become popular in the market um, because in Hadoop 1, like MapReduce and HDFS is tightly coupled. Like if you want to process any data inside a Hadoop, so you have to go through with MapReduce. You need to write the MapReduce jobs, queries, and all that. The other tools inside a Hadoop ecosystem, like a Pig, Hive. So if you are writing your SQL query, HQL queries, or a Pig script, so at the backend, like MapReduce job is executed over the Hadoop cluster. So which is pathetic. Because if someone else having a different like processing technique, and so they are not able to interact with the Hadoop and the data which is stored inside the Hadoop. But just because of MapReduce is tightly coupled on top of Hadoop. So that's why other processing tools, if I'm talking about like PySpark, Spark, Impala, these are the processing like tools. They are not able to connect with the Hadoop in when we use the Hadoop 1 version. So when Hadoop 2 version came into the picture, so Yarn play a very vital role. So MapReduce only just focus on the processing part, does not care about like about the data store, like how to execute the job. So Yarn play an important role. We will cover this topic in a detail, how Yarn play a very vital role when Hadoop 2 came into the picture. So other tools like Spark, Impala, they are ready to like process whatever the data store inside the Hadoop through a Yarn technology. Through the Yarn, they are able to access the Hadoop data, ready to process their data over the Hadoop. So that's why in after 2014, now you can see the picture of Hadoop having a huge demand in the market and all that. So just because of this Yarn is a beautiful yet another resource negotiator. We will cover this topic in a detail, which is very important. Okay, so basically we will focus today mainly on these two tools like HDFS, Hadoop Distributed File System, and the another one we are going to discuss like Hadoop MapReduce and implementation of the MapReduce programming model for the large scale data processing. Okay, and so here we go. The first one we are going to discuss HDFS. So HDFS basically deal with the storage part, and MapReduce is basically deal with the processing part. So firstly we will discuss about this HDFS. So here you can see that some definition of HDFS, like HDFS is a underlying file system of the Hadoop cluster. It provides scalable, fault-tolerant, track-aware data storage designed to be deployed on the commodity hardware, several attribute sets, and HDFS apart from the other distributed file system. Among them, some of the keys that differentiate are that HDFS designed with a hardware failure in the mind. Means what exactly it is telling? Whenever you are design any cluster, na, so you will keep something on your mind. I'll show you. There is a if you want to go visit some website like Hadoop documentation, like a Hadoop cluster. If you gonna search same Hadoop cluster, there is a properties in Geek simple. Yeah, this is Apache Hadoop. If I'm gonna open this one, this is a site. So this is a site from cluster Hadoop cluster architecture. So there are various sites from where you can learn about architecture, but documentation. So they will give you whenever you are designing any. This is a HDFS architecture. This is very important, which I want to show you that. So I would like to suggest you visit on this one, like Apache. So here you can see that all the topic related with the HDFS architecture. So introduction, assumption and goal. This is what I'm talking. Whenever you are designing any Hadoop architecture, so keep these property in your mind, assumption and goals. So I hope you can see. I'm just zooming this part. So I'll just make okay. So but it's too much. Okay, so these are the assumption and goals here. So the first goals whenever you are designing any clusters, the hardware failure. So hardware failure is the norm rather than exception. So an HDFS instance may consist of 100 or 1,000 of server machine and each sorting part of the file system data. So the fact that there are a huge number of component that each component has a non-trivial probability of a failure, so means that some component of HDFS is always non-functional. Therefore detection of a fault and quick automatic recovery from them, there is a core architectural goal of a HDFS. So inside a Hadoop package now, whatever we in a future whatever we are downloading from the Apache website. So this is a Apache website from where you can download the Hadoop package. So here you can see that the release version is written over here. In download section, you can go in a download here. All the Hadoop release version is there. Just click on this mirror site. So this is a Apache website from where you can download the Hadoop version. I'm just opening this HTTP. Here you can see all the Hadoop packages is written. So 2.10 to 3.2. So you can just click any one and you can download any tar package from the Hadoop. So here is a 470 MB. So you can download the package. So Apache is a open source community from where you can download all the Hadoop packages and all that. And the another so inside a Hadoop package na, so they write some algorithm which can like always whenever you are trying to set up the Hadoop cluster na, so they are automatically handle your failures. So in case if any node is down, so it may like if any data node is down, so name node will take care and they will already replicate their data on some other node, some other racks. So so it will won't lose your data and all that. And the other thing like streaming data access. So like application that run on HDFS need streaming access of their data set. So they are not general purpose application that typically run on the general purpose file system. So HDFS is designed more for batch processing rather than interactive use by the user. So means interactive mode, I have you are aware about it. If I'm typing Hive, so you will get a Hive interactive mode. MySQL, so my SQL interactive mode you will get, and you can write your line by line query. So Hadoop is not designed on such a way ki like using an interactive mode you can do these kind of activity. So HDF is designed for more batch processing and the emphasis on high throughput, the data access rather than low latency of the data access. Inside a Hadoop, there are two type: low latency and high latency. I hope you know about the latency, like transferring of data from one place to another place. So in Hadoop, very low latency, you can quickly like transfer your data from one place to another place. There is no high latency. But in case of MySQL and RDMS on these things, there are high huge latencies. Okay, so others parameter like large data set. Hadoop is designed to work on a large data set, ready to store that large data set. So I'm simply coherency model, like write once and read many. If you write your data on the Hadoop cluster, so anyone can read your data and all that. Okay, so moving computation is cheaper than the moving data. This is generally related with the processing part. Moving computation is cheaper than the moving data. So in case of now, in case of like in RDMS, what happened whenever you are going to process any data now? So suppose in RDMS there's same concept like master and slave concept, like one master machine and there are multiple slave machine. But what happened when we are going to store the data? So it will store your data on different machine. But in MySQL, when you are going to process the data, it will move all the data from the different node to your central machine. Then it will start to processing the data. Okay, so this is a centralized system. But in case of Hadoop, the concept is different. Suppose there are 10 machine and your data is distributed in 10 machine. So whatever be the code you have written now, so it will send that code to each and every machine. It don't move your data from those machine. It will send your computation to each machine, and the data which is stored on that machine will process only those data, not like moving all the data on one machine and then start processing. So inside a Hadoop there is a distributed or a parallel processing, but inside this RDMS or a old technology, they are doing the centralized processing, move the data. So that's why it is telling like moving computation is cheaper than the moving data. And then probability across the heterogeneous hardware and the software platform. So HDFS has been designed to be easily portable from one platform to another, and this facility means heterogeneous. Hadoop you can set up on anything anywhere, like Linux operating, Windows, Mac, it's not a homogeneous, it's a heterogeneous. Okay, so these are the property. We are not focusing on the admin side more, but I just tell you that whenever if anyone is working on the Hadoop admin part, so please focus on this assumption and goal. This is very important part here. Okay, that's why I'm telling you, design with the hardware failure, build for large data set, and with default block size is 128 MB. So this is very important part. What is here? So sorry. Inside a Hadoop now, whenever you are storing the data, so always data is stored in the form of blocks. Okay, we will practically, I'll show you the block. So by default, the block size is 128 MB in Hadoop 2, but in Hadoop 1, there is a 64 MB. So I just want to ask you another one question. In Hadoop 2, block size is 64 MB, but in Hadoop 1, block size is 64 MB, but in Hadoop 2, they increase the block size 128 MB. Why? And it is like configurable. You can just configure, you can make it 1 GPA as well. But why they change the block size of this Hadoop clusters? In Hadoop 1 is 64 MB, but in Hadoop 2 they increase it up to 128 MB. So it's a question to you. I'll try to find out this question and let's see who will gonna comment and tell me these things. So optimize for sequential operations. Okay, and rack aware, like rack concept is there, and cross platform and support heterogeneous cluster. So I'll just open my Paint, and through Paint I'll explain you in a better way, like Hadoop cluster and configure. Otherwise we have so many cluster picture of Hadoop. I'll show you. So here you can see that these are the geeks and geeks for geeks. So here you can see that we have a master machine and rest are slave machines. So just close this one. So this is a Hadoop cluster. I think I'll show you some images so you will get an idea. So this is a high level architecture of Hadoop cluster. So here you can see that I'm just trying to open this image. Okay, so better to visit on this website. So what is Hadoop cluster and the first question is what is cluster? So cluster is a collection of the node. Okay, that's why we told you. So inside a Hadoop we have this is my Paint section. So if I'm talking about This is my so in, Hadoop is especially like so Hadoop cluster. If I'm talking about Hadoop cluster, so there are two types of cluster inside a Hadoop. There are two types of cluster inside a Hadoop. One is single node cluster, and the another one is like your multi-node cluster. So multi-node cluster. So what do you mean by single node cluster and multi-node cluster, especially? So single node cluster and multi-node multi-node cluster. Okay, but inside a single node cluster, further there are three mode inside a Hadoop. Okay, so one by one I'll discuss mode of Hadoop. So there is a first one is your standalone mode. Okay, and the another one, if I'm talking about like pseudo distributed mode. Okay, pseudo dis- distributed mode, distributed mode. And the third one, like the last one, if I'm talking about like fully distributed mode, fully distributed mode. So these are the basically the three types of mode inside a Hadoop. Okay. So what is a standalone mode? So so single node cluster means you can consider it a single machine. Okay. So suppose we have a one single machine. Okay, so inside this machine, when we download our Hadoop package, and we will set up the environment of the Hadoop inside a BSRC. So generally, standalone mode is we use like for debugging, like just confirming yes on your machine we have the Hadoop. So inside a Hadoop are function. Yeah. So single node, multi-node. Okay, Hadoop modes. So generally, these are the some basic definition about Hadoop. Hadoop have a standalone mode, pseudo distributed mode, and fully distributed mode. And what is the difference about these three modes? I'm just telling you. So in standalone mode, basically, like you cannot run your any application. Okay. So these are the some modes like standalone, pseudo distributed, and fully distributed. You can also say that the types of mode of operation. So if I'm talking about what is standalone mode, so standalone mode, none none of the daemon will run like name node, data node, secondary name node, job tracker, task tracker. These are the services generally whenever we are service. So no services run on the standalone mode. We use job tracker, task tracker for processing purpose of in Hadoop 1. For Hadoop 2, we use resource manager and node manager. So later on I'll explain you. In Hadoop 1 we generally use job tracker and task tracker, but in Hadoop 2 we use resource manager and node manager. But all these services does won't run on your standalone mode. So standalone mode also means that we are installing Hadoop only in a single system. So by default, Hadoop is made to run in this standalone mode, or we can also called it as a local mode. So we mainly use Hadoop in this mode for the purpose of learning, testing, and debugging. This is the purpose of your standalone mode. So means in this mode, our Hadoop is not a distributed mode because there is no services is running on your system. Your system only telling yes we have the Hadoop package, but it is non-distributed mode. It is not a distributed, it is non-distributed mode. So no services is running on this mode on your system. So when we will do the practical now, so during the practical time I'll explain you at which stage now we can say that we are in standalone mode. Okay, so we will download the package, untar the file, then we will rename it, and then we will set in on the BSRC, and we can say that Now we will type Hadoop version, so we can see that Hadoop version is coming. So it means that Hadoop is set up, but it is a non-distributed mode. We cannot run any service on that mode. Okay, but inside a Hadoop package, we have four files. There are core site XML file, HDFS site XML file, yarn site, MapRat site. So these four XML files we will configure, and we will make our mode is pseudo distributed mode. So in this mode, what happen? Your all services will run like name node, okay, then your data node. So means current your current your current machine having master as well as slave, means एक सिंगल मशीन में ही तुम्हारा मास्टर भी है और स्लेव भी है, मतलब उसी में डेटा भी रखा जा रहा है, उसी में भी डेटा प्रोसेस हो रहा है, सब कुछ सारी सर्विसेज चल रही हैं. सो नेम नोड, डेटा नोड, योर secondary name node, then your resource manager and node manager, all services running on a single daemon, on a single machine. सारी तुम्हारी जितनी भी सर्विसेज चल रही हैं. Now this mode generally we use for debugging purpose. जितने भी डेवलपर होते हैं ना, we are learning. अभी जैसे अनूप you are learning. So in this mode you can load your data on your machine, you can process your data on a machine. लेकिन जब when you are working on company ना, so you will get a fully distributed environment. So right now, whenever anyone is learning Hadoop na, so he always prefer this pseudo distributed mode. Set up these four configuration file and make it all the services running on this mode. So you can see the definition in detail. Like pseudo distributed mode or a single node. In pseudo distributed mode, we also use only a single node, but the main thing is that the cluster is simulated, which means that all the process inside the cluster will run independently to each other. Means कहने का बोला है कि each services take each JVM, हर एक सर्विस को एक JVM मिल जाता है इसमें. सो ये इंडिपेंडेंटली काम करते हैं, मतलब एक ही मशीन में है बट इट इंडिपेंडेंटली वर्क. अपना नेम नोड एक अलग जेवीएम में चल रहा है, डेटा नोड, ये सारी सर्विसेज अलग अलग जेपीएम में इंडिपेंडेंटली काम कर रहे हैं. और एक तरीके से ये ना प्रोडक्शन का रेप्लिकेट है. यहाँ पे जो भी काम कर रहे हो ना तुम, वो सेम टू सेम काम वहां करोगे प्रोडक्शन में. So that is a benefit inside it. And all the daemons that are run name node, data node, secondary name node, resource manager, node manager will be running as a separate process on separate JVM. So or we can say run on a different Java process. That is why it is called a pseudo distributed mode. So one thing we should remember, that as we are using only the single node setup, so all the master slave process are handled by the single system. So name node and resource manager are used as a master, and data node and node manager use as a slave. So generally क्या होता है, data node and node manager consider as a slave machine. So a secondary name node is also a master, and the purpose of the secondary name node is just to keep the hourly basis backup of the name node. We will discuss like name node का भी तरीका है कि name node किस purpose के लिए use किया जाता है. It will provide backup for a name node every hour, do a checkpointing and all that. So Hadoop use for development and debugging purpose. इस mode को हम लोग use करते हैं basically development और debugging purpose के लिए. मतलब हाँ, आप इसमें अपना data upload करो, उसको process करो, अपनी अपनी जॉब रन करो. और बेसिकली मैंने जो चार फाइलें बताई थी इनको कॉन्फ़िगर करेंगे. मैपराट साइट एक्सएमएल कोर, एचडीएफएस, और यान साइड भी होती है हडूप 2 में, बट हडूप 1 में वी डोंट हैव सच फाइल यान साइड एक्सएमएल फाइल. So here you can see that all the services running on the pseudo distributed mode. So once you are perfect on this pseudo distributed mode ना, then when you will gonna enter on your industry, so वहाँ पे आप देखोगे ना तो एक मास्टर होगी. पहली बात तो वहाँ पे कंसेप्ट होता है, वहाँ रैक का कंसेप्ट होता है. ऐसे बहुत सारे तुम्हें रैक दिखेंगे वहाँ. ऐसी रैक होंगी. एंड देन इनसाइड ईच रैक आपकी ना मशीनें होंगी. आपने देखा होगा, आई होप यू हैव सीन द डेटा सेंटर्स. यू कैन चेक द डेटा सेंटर्स, उनमें रैक्स होते हैं. और एटलीस्ट ईच रैक कंसिडर 30 नोड्स, कम से कम 30 नोड्स होती हैं. मैं बार बार नोड कह रहा हूँ तो आई होप यू अंडरस्टैंड. नोड मीन्स लाइक सिस्टम, लैपटॉप, ऐसे ही कंसिडर कर लो उसे. So node generally having these are generally called the servers and having a huge configurations like 64 GB RAM, 120 GB RAM, like this type of. So these are the rack. और होता क्या है when we are dealing with the and these all are rack having on top of like switches is there. ये switches होते हैं. These are generally called switches. And these switches basically connected. Each node is connected with these switches. हर node switches से connected होती है. ऐसे कनेक्टेड होती है. सेमली यहाँ पे भी वही काम हो रहा था, यहाँ पे भी वही काम हो रहा था. और here you can see that in pseudo distributed mode all services running on the same node. बट लेकिन वहाँ डिफरेंट होता है. क्या पता नेम नोड यहाँ चल रहा है, इस वाले में नेम नोड सेटअप कर दिया. सबके लिए अलग अलग मशीन है और बाकी सब आपकी डेटा नोड है. मान लो ये D1 है, ओके, ये आपकी यहाँ पे आपकी D2 आ गई. मीन्स ऐसे पूरा मतलब सेटअप करके रखते हैं वो लोग. पूरा D2 आ गई, ये आपकी D3 हो गई, ऐसे ही है. ये आपकी D4, ये आपकी D4 हो गई. मीन्स एक मास्टर होती है और बहुत सारी स्लेब्स होती हैं. D4 हो गई, ऐसे D5 हो गई, ठीक है. और पता चल रहा है कि नेम नोड के साथ यू आर कीपिंग रिसोर्स मैनेजर विद द नेम नोड, लेकिन आप उसको अलग भी रख सकते हो. इट्स अप टू यू. इट्स अप टू यू कि रिसोर्स मैनेजर को कैसे रखना है आपको. और हर एक डेटा नोड के साथ आपका क्या होता है, हर एक डेटा नोड के साथ आपकी एक नोड मैनेजर भी होता है. N1, सॉरी इसको N3 कर देते हैं. हर डेटा नोड के साथ आपका एक नोड मैनेजर भी होता है. हर एक डेटा नोड के साथ नोड मैनेजर की ये चीज़ें. तो जब आप डिस्ट्रीब्यूटेड मोड पे काम करोगे ना, तो ऐसे ही कुछ आपको फिगर आउट ऐसी चीज़ें मिलेंगी जहाँ पे आपका काम चल रहा होगा. और देन वी हैव सेकेंडरी नेम नोड ऑल्सो. सेकेंडरी नेम नोड भी किसी एक मशीन पे होगी. सेकेंडरी नेम नोड, नेम नोड. ओके, सो कुछ हाई लेवल आर्किटेक्चर आपको ऐसे ही दिखेगा. एंड आई शो यू इन फिगर एज वेल. ये आपकी सारी सर्विसेज देखो. इस केस में क्या होता था, इन केस ऑफ सूडो डिस्ट्रीब्यूटेड मोड all machines are running on the same, all services, all the daemons are running on the same machine. But in case of fully distributed mode na, all services running on different machine. So this is most important one in which multiple nodes are used. Few of them run the master daemon that are name node and resource manager, and the rest of them run the slave daemons that are data node and node manager. Here Hadoop will run on the cluster of machines are a node, and here the data that is used distributed across the different node, the actually the production mode of the Hadoop. इसको production mode भी कहा जाता है. So industries everywhere we are using this fully distributed environment. So once you download the Hadoop in the tar file format, zip format, then you install it in your system and run. You run all your process in single system. But here in a fully distributed mode, we are extracting this tar and zip file to each of the node in the Hadoop cluster, and then we are using particular node and particular ones. Okay. So this is and if I'll see the cluster. This is a cluster as I am talking about. So here you can see the diagram already. इसको मैं close कर लेता हूँ. So here you can see cluster का एक figure देख लेते हैं. Cluster हमारा कैसा होता है. I think it's ये देखिए. So we have rack. देखो ये racks होती हैं, rack 1, rack 2, ऐसे बहुत सारी racks होती हैं. और हर rack में आपकी मशीनें होती हैं, at least 30 to 90 services. So here you can see that name node we have on top of, then data node. Name node की position कहीं भी हो सकती है, but दिखाने के लिए. And these are data node, then secondary name nodes. So all data node, resource manager, these are data node, and all are connected with the rack switches. And these all are rack connected with switches. So ये सब interconnected है. Okay. So this is a concept like of the clusters. So we like load our data inside it. Okay, so I'm taking a pause. So yeah, Anup, you have. So here we have like fully distributed mode, and these are the modes we have, like standalone, pseudo distributed, and fully distributed mode. Okay, and in this mode we have a different service. So this is a high level architecture of Hadoop. So here I'm gonna close my session. Okay, so please don't forget to watch my previous video, and we will cover this section on our new video. So thank you. I'm just stopping.